consider this quadratic. How does this factor? X. Okay, and so we end up with 1 and -4, right? That's easy. Let's make it just a little bit harder. This one we factor in a different way. Use the box. So 8x squared minus 15 times those together, I get negative 120x squared. Are there factors of negative 120 that add to be negative 14? 7 does not go into 120. No. 20 and 6. So negative 20x, 6x. So that would give me 4x, 2x, negative 5, and 3. And then 2x minus 5 equals 0. So what would the root be? 5 halves, and this one would be negative 3/4. Okay, we got that? What about this? Let's do... I don't know. Yeah. This is... Anyway, I'll tell you about that later, but not when I'm on camera. Okay. Can we factor this? Is it a quadratic? It's a quartic, but could we pretend it's a quadratic and still factor it? Why? What is it about these two exponents that allows me to treat it like a quadratic even though it's not? Right, that's it. So if I treated it like this exponent is twice as big as that exponent. And that's the pattern for quadratics that we rely on in order to factor. So I could, instead of putting x and x, what would I put there? X squared, and then we'd have minus 9 and plus 1. This one's going to factor into a difference of squares. And this one actually factors into a sum of two or a difference of two imaginary. Yeah, it's like x plus I and x minus I. Okay, but that's not what we're doing today. So if I had x to the 12th minus x, what would need to go there in order for that to factor? Would have to be a 6. So in theory, if we have a trinomial where the first exponent is double the second exponent, we can pretend it's a quadratic and solve it. Okay? That one actually didn't work, but whatever. Okay, so here, do we have the pattern we were after? Is the first exponent double the second exponent with a constant at the end? Yes. So we're going to do something that I wish I would have learned as a junior. It's called U substitution. It didn't exist when I was in 11th grade. I didn't learn it till calculus. In calculus, it is extremely useful. You will do U substitution as often as you factor in calculus, perhaps more. Calculus, all the way. Calculus, all the way. Okay. 1050 is this class. Calculus is calculus. Yes. What's in your hand? You can go get it when we're done. All right, so here's what we're going to do. We are going to create our own pretend variable we're going to call u, and we're going to choose u equal to whatever is in the x to the first place in this quadratic equation. So here I have 1 times 4 to the x. Well, I don't even need to write that. This term is going to be my u term. I don't know why we use u, but again, in calculus, u substitution makes very, very difficult problems very, very easy and doable. So I'm going to write u equals 4 to the x. Now I'm going to substitute everywhere I see 4 to the x with the variable u. So if I were to rewrite this, it would be, what is 4? Well, how would you split that? If I take the 4 out and the x out, what's left? Squared. So it's u squared minus u minus 2 equals 0. Just as a side note, if I had 4 to the 2x, can I split this? When you multiply two exponents together, there's another way to represent that. No, you're going the wrong way. It's the same as 4 to the x to the second, right? Because if I had 3 squared to the 4th, isn't that just 3 to the 8th? Which is the same thing, oddly, as 4 squared to the x. But this is the one we rely on, because I said this is u, and then I squared it. Now, there's a lot more going on there than you actually need to realize, because if it's set up so that this is twice as much as that, then it will always be u squared and u. That's the nice thing about today. It'll get harder when you reach calculus. Okay, so let's solve this. U minus 2 and u plus 1 equals 0. So u is either 2 or u is negative 1. So what I've done is taking what looks like an incredibly difficult equation, thrown out the tough stuff, solved it as a quadratic, and now I have to put that 4 to the x back in, which isn't hard to do. So now I'm going to substitute this back in. So I pretended it was easy, and then solved it, and now I'm just going to put that stuff back together. 4 to the x equals 2, and 4 to the x equals negative 1. So how do you solve this? ln both sides. So x ln 4 equals ln 2. Divide by the ln of 4. Now, before you solve this, if this is the change of base version, what would the regular logarithm look like? Log base 4 of 2. 4 to what power is 2? The 1/2, the square root, right? Which you could have figured out from here. 4 to what power is 2? 1/2. Or, if you don't know that, just plug in ln 2 over ln 4 and you get 1/2. Shem, you all right? Okay. So now, over here, x ln 4 equals ln negative 1. So I'm going to divide by the ln of 4. So ln of negative 1 divided by the ln of 4. Uh-oh, what did I do wrong? Why can I not do it? It's not I. Well, look here. How many 4s do I need to multiply together to get a negative number? You can't. If you raise 4 to the 2 or to the 3 or to the 4, it's only going to get bigger. What if you raise it to the 1/2 or the 1/3 or the 1/4? It's going to approach 0. What if you raise it to a negative number? it's going to flip upside down and also approach 0. So no matter what you do, you cannot create, or you cannot take the logarithm of a negative number. And the reason is exponential graphs and logarithmic graphs are inverses, and we'll talk more about this later. So if I were to graph an exponential curve and I were to invert it, will this bank account ever be worth 0 or less? No. The inverse of that is going to look like this. So in an exponential graph, an exponential growth or decay graph, you cannot reach the negative values. The range cannot be 0 or below. Well, if we invert it in a logarithmic graph, there are no domains that are negative. You'll see more about that later. So what you need to know today is you cannot take the logarithm of a negative number. There's no way to use a positive number and multiplication and exponents to create a negative. Now what if I started with a negative and I raised it to a power? That alternates, right? And in fact, it alternates in such a crazy way that we only do that with sequences. So your base will never be negative with logarithms unless it's a sequence. And then your answer has to be a whole number anyway, so it doesn't matter. Okay, so let's look at the second one. What am I going to choose as u? E to the 2x. Could I choose e to the x? I could. Then it would be u to the 4th minus 3u squared minus 18, which is going to make it a little bit harder than it needs to be. So I write u equals e to the 2x. So substituting in e to the x for u, I get u squared minus 3u minus 18 equals 0. Does that factor? Negative 6 and 3. Are they both going to work? The 3 won't. How come? Oh, it says positive right there. Right. It will be negative, and can e to the 2x equal a negative number? No. So we can throw that one out. What if they're both going to be negative? Then it would be no solution. What if they're both positive? It just has 2 answers. So it depends on the quadratic. If the quadratic has 2 negative answers, there's no solution to that problem. If the quadratic has 2 positive answers, then there are 2. So I have u equals 6. Then I come up and grab my e to the 2x and stick it back in. E to the 2x equals 6. Now what? ln both sides. So 2x ln e equals ln 6. You guys are smart and you remember that ln of e is 1 because it's base e, and e to the first is e. So that goes away. Just divided by 2. So the answer is ln 6 over 2. It's not the ln of 3. That does not work. Yeah, so the ln of 3, no, not the same number. Okay, so there's a mistake on this last one. That 20 is actually supposed to be 4 times 5 to the 3x. Do I have the quadratic pattern I require? Is the first exponent double the second exponent? Yes. So what is my u going to be? 5 to the 3x. Could I choose 5 to the x? I could, but it's going to make factoring, well, depending on the problem, it may be a little harder. So u squared plus 4u minus 12 equals 0. Does that factor? U minus 6 and u plus 2, but I can throw out the u plus 2 because it will give me a negative root, and there's no way for 5 to the 3x to be a negative number. Did I mess up? Oh, thank you. I knew I hired you for a reason. Okay, let's throw this one away. Checks in the mail. Ask Katie. She knows all about it. So, 5 to the 3x equals 2. We ln both sides. 3x ln 5 equals the ln of 2. Which one should I divide first? It doesn't matter. If you have 12 and you divide 3 and divide 2, you're going to get 2. If you have 12 and you divide 2 and divide 3, you're still going to get 2. If you divide together, you need to use parentheses, but that will work too. So this is what I would do. ln2 divide ln5 divide 3. Or you could have done ln2 divide 3 divide ln5. But if you do them together, you have to put parentheses around them. So it would look like this. And that would also work. So that gives me 0.14. 0.14 is the only x value that will make that equation equal 0. Okay? All right. Get to work.